All right, here we go. So, quadratic formula, working out nicely with these numbers. Let's take a look at this problem. All right. It says use or solve for x using the quadratic formula. I'm always going to encourage you to write down the quadratic formula. That process alone might help you, quote unquote, memorize it. Okay? And after you write down the quadratic formula, my suggestion is also to list what A, B, and C are. So A is the coefficient of x squared, B is the coefficient of x, and C is the floating constant. Now, I did say that Desmos / a graphing calculator can do this entire problem for you if you plug things in correctly. So let's see what that looks like. That would look like this. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Parentheses are key here. They indicate, first of all, underneath here when we're squaring something, we need those. Secondly, they're showing us that we're doing multiplication over here. And again, I'm fine at this point in our lives going to Desmos and using the calculator to help us. If I do that, and I type this in, oops, the opposite of negative 12. Now I can't type in plus or minus, so I can only type in one operation at a time, so I'm going to plug in just the plus. The square root of negative 12 squared minus 4ac all over 2a. Front row, undefined. In the real number world, in the real number universe, which up to this point we had been dwelling in, you'd be like, I guess there's no answer. Moving on. Well, now we have this new universe of numbers with complex numbers. So when you get into a situation where it says, I can't do that, we're going to make it do that. Now the calculator doesn't understand, Desmos doesn't understand complex numbers. You do. Okay? You know what to do. All right? So, we're going to come back here. Here's the problem. Stay with me. The problem, I didn't want that one. I want this one. The problem is here. Okay? There's nothing wrong with the opposite of negative 12. That's 12. There's nothing wrong with dividing by 2. So the undefinedness happens in here. All right? So let's keep going, and let's, just for now, the opposite of negative 12 is 12. 2 times 1 is 2. For now, let's take what's in this red box, that expression, that's where the problem is, and let's figure out what just that is equal to. So I'm going to go back to the calculator. Not because I'm stubborn. I know it already told me it's undefined, but I'm going to take what's in that box, this thing right here, and I'm going to get a value for that. Just that. No radical, you see? And what do we get? Negative 16. That's why the calculator said undefined, because it was trying to take the square root of negative 16. It doesn't know how to do that. But you do now. It's possible if we include imaginary units. Okay? So if I'm getting negative 16 down here, I'm not going to stop and say I can't do it. Now I'm going to say, no, I can do this because I know how to take the square root of negative 16. So we're going to do that. Remember that to take the square root of a negative number, That's really just the square root of that number times the square root of -1. And the square root of -1 is I. So really this is 12 plus or minus I, and the square root of 16. What's the square root of 16? 4. So I4, not I4. I'm going to call that 4I over 2. And now, I know all of you here in class can see this. Hopefully the people at home can see this. I tried to line it up perfectly, right? When we get to this situation where there's that binomial on the top over one number, what did we do? We broke it up. We're going to do that here. We're going to separate this now into one problem where it's addition, and we're going to take the subtraction and do that one over here. Now, pause for a second. Again, I know you all can see this. Hopefully the people watching the video can see it. I don't know. Hopefully all of my many adoring fans can see this. My highest ranked video right now, or most views, 27,000.
Oh yeah.
27,000. And climbing. I check it every day. It's the first thing I do in the morning. I'm just kidding. That's not true. Okay. I can do -4 plus 8 and then divide that by 4. I can't do 12 plus 4i. I can't, right? That they're not like terms, right? But we talked about this yesterday. When you have a complex number in the numerator and a single denominator, we split it up. Because a complex number has to have two parts, a real part and an imaginary part. It can't be one fraction. I know it's nitpicky, but that's the way it is. That's how we roll with this. So I'm going to separate it again. It's going to say 12 over 2 plus 4 over 2 with an I. And this is going to be 12 over 2 minus 4 over 2 with an I. Somebody asked me this question in my last class. How come the i's not in the fraction? Doesn't matter. We kick it to behind that just because. You can leave it in the numerator, that's fine. But it's a bit more proper to put it right next to it. And then these can be reduced. That's 6 plus 2i. And this is 6 minus 2i. So it does have solutions. It is defined. We do get values for x. They just happen to be complex numbers. All right? So even when the calculator says, I can't do that, we're smarter than the calculator. We know how to take the square root of negative numbers, and we should. Okay? All right. Now we're going to do another one that's going to be way worse.